Okay, welcome to my class. Good morning. Here, at first recap assignment 10. Okay, assignment 10 recap. This look here. Are you watching these things? Okay, this is this question. First one was, what is electrophile? Electrophile means electron-like, so it should be positive. So electron deficient species are electrophile, which accept a pair of electrons. They are electrophile. So positive things are electrophile, like this is nitro, sulfur trioxide. It is electron deficient compound. It is not full octet. We know octet 8 electrons. Here is 2 electrons, 6 electrons. So it is electron deficient compound. And this is the nucleophile. They like a nucleus, like positive charge. Positive nucleophile. What is nucleophile? They like a nucleophile means nucleo come from nucleus, and phile means like, nucleus like. That means positive like. So there should be negative. They are negative. So they are electron rich. The reagent having strong attraction to nucleus or positive nucleus, they are called nucleophile. They are itself negative. Nucleophile two types: negative nucleophile, neutral nucleophile. This is ammonia and water is negative nucleophile because they have lone pair electron. This is one lone pair electron. Water has two lone pair electron. Okay, this the substitution reaction occur by nucleophile. This is called nucleophilic substitution reaction. This is given. What do you mean by nucleophilic substitution reaction? The substitution reaction in which occur by nucleophile, it is called nucleophilic substitution reaction. It is expressed SN. This is nucleophilic substitution. Nucleophilic substitution two types: SN1, SN2. SN1 reaction occur by rate determining step is 1. Rate depend on the one concentration of the only reactant, alkyl halides. For this reason, this is SN1 reaction. SN2 reaction occur two step, one step in which rate determining step, rate determining step is reaction rate depend on the nucleophile and also reactant. For this reason, it is called SN2 reaction. Okay, this reaction, why this occur SN1 reaction? This reaction occur because this is carbocation form. Here is a 3-degree carbocation is stable. So this is show. If we see this, why this is 3-degree carbocation form? This is one alkyl halide. This is carbon. This carbon, this chloride. This carbon contains halogens. This carbon is called alpha carbon. This alpha carbon. The carbon carrying halogen. This is called alpha carbon. Okay, this alpha carbon contain one alkyl group, two alkyl group, three alkyl group. If 3 alkyl group, this is the 3-degree. It is possible to form 3-degree carbocation. 3-degree carbocation is most stable. 3-degree most stable carbocation prefer SN1 reaction. So this reaction prefer SN1 reaction. SN1 reaction occur in 2 steps. It has 2 steps. First step, 3-degree alkyl halide dissociate. From 1-degree carbocation. This is dissociate slowly and form carbocation. And the second step, the nucleophile. This is the nucleophile attack the carbocation and give the product. Okay, this is the second. It is why this is SN1 reaction, because we know the rate determining step is the slow step. Slow step is the rate determining step. Slow step, this is here concentration is depend only the alkyl halide. There is no nucleophile. In the slow step is only nucleophile. Look, this is alkyl halide. There is no, here is nucleophile. second step, rapid step, but rate determining step is the slow step. Here in slow step is the only alkyl halide. For this reason, this is SN1 reaction. Okay, second is the this is the alpha carbon. This alpha carbon contain one alkyl halide. This alpha carbon contain one alkyl halide, so this is 1 degree alkyl halide. So 1 degree alkyl halide prefers SN2 reaction mechanism. So this is a flow SN2 reaction mechanism. This SN2 reaction mechanism occur here. Nucleophile attack the carbon atom, alpha carbon, opposite to the halogen. This side is halogen. Nucleophile attack to the opposite side of the halogen. This nucleophile attack the alpha carbon. Here is a bond. A bond is forming. Here is a bond is breaking. This is position. This position is called unstable complex. And finally, this is the leaving group. Leave completely. Here is a formed. Here is a OH and carbon form a bond. This is the form bond. This compound form bond. And leaving group left here. Chloride left from completely from here. And this product is the look conversion. This the conversion is like this is 100% conversion. This is reverse umbrella. 100% conversion product. In the product formation, it 100% conversion occurs in SN2 reaction. Like this is a product reactant, and product is 100% conversion. Okay, this is the recap of last assignment. Have you any question here? Okay, factor affecting the reaction rate of SN1 and SN2. Formation of reagent, concentration and reactivity of nucleophile, leaving group, rule of solvent. So this is the at first formation of reagent affect the reaction rate of SN1 and SN2 reaction. Like this is factor affecting the rate of reaction. Okay, what are the factors affecting the rate of reaction? I have already told 4 factors. Say you, anyone? What are the factors affect reaction rate of SN1 and SN2?
Formation of reagent, then leaving group.
Leaving group, তারপর rule of solvent. আচ্ছা, rule of solvent হচ্ছে যে solvent থাকে না পট যদি protic solvent হয়, protic solvent মানে কি? Protic solvent, aprotic solvent. Protic solvent, the solvent contain hydrogen atom. They are protic solvent, like water H2O. Water, what is this? Water OH minus H plus. Here is the hydrogen present, so the protic solvent. Aprotic solvent which don't contain hydrogen atom. Okay, so protic solvent prefer SN1 reaction, and aprotic solvent, if you see the solvent is given aprotic solvent, like dimethyl sulfoxide DMSO or acetone, they are aprotic solvent, they prefer SN2 reaction. Okay, factors affecting are this law? Factors affecting factors affecting the rate of reaction. the factor affecting spelling this wrong here, affecting the reaction rates of okay, SN here is the SN is subscript, but I can't write here. SN is subscript, and SN N here, N is subscript. As this N is subscript. Look, I can't write here. It is not possible to write here. I try to write here. Can this possible? Yes, possible. It is here. I can do. Okay, this is the subscript. Okay, at first is formation of reagent. Okay, this is the no, this is we know this is okay. Okay, what is this? This one is this one is this is a alkyl halide, alkyl group. I can write this is R this way. I can write this way. I can write this is R3 means this is alkyl. This is Cl. Okay, alkyl halide. Okay, this alkyl may be methyl, ethyl, methyl, propyl, anything may be. So this is reaction like R or Me. This is alkyl group. Like I gave here is a propyl. This is also alkyl group. I gave here ethyl group. And this is okay. I gave here only hydrogen. No, this is okay. Okay, this alpha carbon. The carbon which carry halogen atom. This is the alpha carbon. This alpha carbon contain how many alkyl group? This is one alkyl group. This is two alkyl group, three alkyl group. So this is the 3-degree alkyl halide. So 3-degree alkyl halide form stable carbocation, most stable carbocation. So this is prefer if most stable carbocation form. So it prefer SN1 reaction. But this the just like methyl halide. Just methyl halide. Like I gave chlorine, methyl halide. This carbon methyl halide no alkyl group. So this is methyl halide. If one alkyl halide like this is, it will be 1-degree alkyl halide, 1 degree, but there is no methyl group, only hydrogen. Okay, this so it is methyl halide. So methyl halide here, this in a methyl halide, nucleophile easily can attack the alpha carbon. So it easily can attack the alpha carbon. There is no steric hindrance, no bulky group. Okay, so this if easily alkyl halide can attack, this is prefer SN2 reaction mechanism. Okay, so SN2 mechanism. So methyl halide prefer SN2 reaction. but a 3 degree alkyl halide prefer SN1 reaction. Okay, SN1 reaction mechanism flow. Okay, but why here SN2 mechanism is not preferred? Because this is the bulky group. Nucleophile don't attack easily. Here it cannot easily because steric hindrance. This is big group. Steric hindrance. I show these things. If I show this bond here this way, this is the CH3 bond. If I show this bond this way, 3 hydrogen here. This hydrogen. There are many steric hindrance. This also contains steric hindrance. So here SN2 mechanism, nucleophile can't easily attack. For this reason, it don't flow SN2 mechanism. It form SN1 mechanism because it form 3 degree alkyl halide form a stable carbocation. So this flow SN1 mechanism. And second topic was your concentration and reactivity of nucleophile. Concentration and reactivity of nucleophile. This is the concentration and reactivity of nucleophile. SN1 reaction. Nucleophile. Look, this is nucleophile. SN1 reaction don't flow the reactivity of nucleophile. Concentration SN1 reaction. SN1 SN1 reaction does not depend on the concentration and reactivity of nucleophile. SN1 reaction does not depend on the nature and concentration of nucleophile. Okay, this is I have given a point. SN1 reaction does not depend on the nature and concentration of nucleophile. Do you know anyone why it does not depend on the nature and concentration of nucleophile? SN1 reaction why does not depend on the nature and concentration of nucleophile? Have you anyone give answer this question?
Because it has a rate determining step.
So, rate determining step. Your answer is partially half. You 20% half. 30% given. You need at least 60% correct answer. You close to answer. SN1 reaction. Look, this is SN1 reaction. The rate determining step. Which one is the rate determining step? First step or second step?
First step.
First step is the rate determining step. Why?
Because it is slower step.
Slow step rate of reaction. Where this is? Oh my! I lost my picture. Where? Classwork এটা আছে আচ্ছা আচ্ছা look, this is the SN1 reaction first step. This is the slow step. This step here is the slow step. Depend the rate of reaction depend on the slow step. I explained last class why rate of reaction depend on the slow step. This is the slowest step. This step rate of reaction depend. Here there is no contribution of nucleophile, only alkyl halide. So here this is the rate determining step, but there is no contribution of here nucleophile. For this reason, SN1 reaction does not depend on the nature and concentration of nucleophile. Okay. So SN1 reaction does not depend on the nature and concentration of nucleophile, but SN2 reaction depend on the concentration of nucleophile, because here the rate determining step is the one step. This is the here the step unstable complex. Here concentration of alkyl halide, also nucleophile depends. So SN2 reaction depend on the concentration and nature of nucleophile. In the rate determining step, this is the one step. This is the rate determining step is the one step. Here is a, so here the concentration is depend on the nucleophile and alkyl halide. So SN2 reaction depend on the concentration and nature of the nucleophile, but SN1 reaction does not. Okay, third step was leaving group. Leaving group. So the atom or substituted, or atom or group of atoms substituted by nucleophile substitution reaction is called leaving group. This is the leaving group. This is atom. Sometimes here group of atom also contain. The atom or group of atom substituted. Here it is substituted by OH. Substituted. The atom or substituted group substituted by a nucleophile substitution reaction is called leaving group. So here is a chlorine is the leaving group. Chlorine is a leaving group. Hello? Unstable complex where this the substance is not এটা তো বুঝতেছো এটা স্টেবল না, কারণ হচ্ছে এখানে বন্ডটা ভেঙে যাচ্ছে এখানে বন্ডটা গঠন হয়ে যাচ্ছে এরকম অবস্থা। বন্ড এখানে কার্বন here is a transition state. A complex is the look, this is not easy form, complex it is. Okay, this is here is the which one leave. This chloride leave. The chloride is the leaving group. The atom or group of atom which leave from the alkyl halide during the nucleophilic substitution reaction is called leaving group. This is leave from the alkyl halide. So chloride is here the leaving group. Okay, the better leaving group nucleophilic substitution reaction proceed rapidly. So which one is the better leaving group? Among halide ions are better. Halide ions are act as a leaving group. Among halide group, iodide is the best leaving group. Then bromide, then fluoride, then iodide is the halogen atom. Iodide is the best leaving group. Then bromide, then chloride, then fluoride. Okay, so if we see the this one, if we see this the iodide here present, so it can give easily SN2 reaction because iodine easily remove from the alkyl halide easily, so it give the SN2 reaction best. But fluoride don't leave properly. This is the fluoride This the living group is the fluoride. Fluoride, it don't live easily. It don't live easily in a room temperature. It don't live easily. So it remain in the normal concentration inert. Fluoride don't easily removed because it is not best living group. So this is the best living group. Iodide is the best living group, then bromide, then chloride, then fluoride. Okay, so this is give the SN2 reaction, but this does not give, because this is remain inert. It don't live easily. Because why? Iodine is a big molecules, big atoms. It don't bond properly, so it want to remove this bond, want to break this bond, so it remove easily. So it is the best living group among halogens. Iodide is best living group, then bromide. এই সুয়াদা কি করছো তুমি এখানে? Then bromide, then chloride, so then fluoride. So iodide is the best living group. Okay, this is the living group. Order of reactivity of living group. This is the order of reactivity. Okay, 10 minutes remaining. I will take meeting again if finish the order of reactivity of halogen ions of living group. Oh no, living group halogen ions. Okay, halogen ions. Okay, next topics, living group and solvent. I discussed already. Protic solvent like protic solvent water. Protic solvent water. Water has positive part also here. This is the proton content. Okay, this is the protic solvent. Okay, protic solvent prefer SN1 reaction. SN1 reaction, they prefer SN1 reaction. Okay, protic solvent. Like protic solvent, this is the this ethanol of the protic solvent. Protic solvent, which one is the positive side? It is has CH3 iodide and H plus. It contains also proton. Okay, so this is methanol is the protic solvent. So protic solvent prefer SN2 reaction, and aprotic solvent prefer SN2 mechanism. Aprotic solvent aprotic solvent prefers SN2 mechanism. That SN2 mechanism SN2 mechanism. Aprotic solvent like this, like DMSO, dimethyl sulfur oxide. Dimethyl sulfoxide, DMSO, dimethyl sulfoxide, acetone. They are aprotic solvent. Okay, this is the DMSO, dimethyl sulfoxide, acetone, also DMF, 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 this solvent DMF, this is the dimethyl formaldehyde. Okay, this is the formide. This is also this aprotic solvent, they prefer SN2 mechanism. So I have discussed the affecting reaction rate of SN1 and SN2 reaction. This one rule of solvent, like SN2 reaction, this is the comparison between SN1 SN2 reaction. SN2 reaction occur in one step, SN1 reaction occur two step. It is second order reaction because the rate of reaction depend on the reactant and nucleophile. It is first order reaction, rate of reaction depend on the reactant alkyl halide. It is prefer strong reaction prefer strong nucleophile. The reaction prefer weak nucleophile. Weak nucleophile prefer SN1 reaction. Strong nucleophile prefer SN2 reaction. It is bimolecular SN2 reaction. This is SN1 reaction. Concentration, higher concentration of nucleophile is needed. SN2 reaction. It is lower concentration. It not depend also on nucleophile. This the non-polar aprotic solvent is better. Non-polar and aprotic solvent is better for SN2 reaction, like DMF, DMF, dimethyl, dimethyl formide, DMFO, DMSO, the dimethyl sulfoxide. They prefer non-polar and aprotic solvent prefer SN2 reaction, and polar and protic solvent is the formation of carbonium ion. So alcohol, ammonia, hydrogen fluoride, they prefer SN1 reaction. This is the reactivity. Methyl halide is the best for SN2, then 1 degree, then 2 degree, 3 degree. Here is a 3 degree alkyl halide best for SN1 reaction, then 2 degree, then 1 degree, then. Here the structure 100% conversion occur. I have shown this the figure, reactant and product of the SN2 reaction. It is 100% inversion of configuration take place. Inversion of configuration does not occur. Okay, problem here. Have you seen this problem? 3 minutes. What is a spectator ion? You know this the spectator ion. The ions which don't participate in the reaction, they are spectator ions. You know this the HSC level. Molar solution is standard solution. The solution which contain 1 mole of solvent, like 1 mole solvent, like water contain 18 gram, sodium hydroxide contain 1 mole sodium hydroxide means sodium 23, oxygen 16, and hydrogen 1, 40 gram. 40 gram sodium hydroxide if dissolved in 1 liter water is called 1 mole solution. Okay, molar is also called the molar solution. This is 1 mole solution is called molar solution. Standard solution. What is standard solution? The solution which concentration we know, this solution is called standard concentration. The molar concentration we know the concentration. For this reason it's called standard solution. Like semi-molar solution, why semi-molar solution is standard solution, why decimolar solution is standard concentration solution, this question come here. Okay, write down the mechanism of production of A. This is the A. Okay, I have a question. Write down the mechanism of the A. Okay, this is the reactant alkyl halide. Okay, which mechanism will flow this reaction? Okay, क्या देते पर आंसर? Give my question answer. Question number 3. Write down the mechanism of production of A, product A. This reaction. Which mechanism flow this reaction?
SN1.
Why?
3 degree alkyl halide.
Good, alkyl halide. Okay. Okay, then second question is, 2 different carbonyl compound are obtained when compound B undergo first ozonolysis and then hydrolysis. Two different carbonyl compounds are obtained when compound B undergo. Okay, when do we, if we this aqueous solution, this is a potassium hydroxide is aqueous. Aqueous means dissolve in water. Aqueous means dissolve in water. Here is the product B, alcohol. Alcohol, ALC means alcohol. If is alcoholic solution, potassium hydroxide alcoholic solution, it form alcohol. We see, but if the alcoholic solution, it form alkene. I show the mechanism this reaction next class. If the reagent is alcoholic solution, it form not alcohol, form alkene. So if the alkene undergo ozonolysis reaction, we know this either 2 aldehyde or 1 aldehyde, 1 ketone or 2 ketone is formed. Two different carbonyl compounds are obtained. Okay, I show this reaction, but if we present aqueous solution, it form, okay, less than 1 minute remaining. Aqueous solution contain, it form alcohol. But if aqueous solution form alcohol, if alcoholic solution, ALC means alcohol, it form alkene. Here form B product is alkene. We know alkene undergo ozonolysis reaction. Okay, here I have already discussed these things. I also discuss in the next class these things. No, I will not discuss because ozonolysis reaction I have already taught. Okay, then ozonolysis product, and I will explain the mechanism how if the reagent is alcoholic, how alkene is formed. I will show these things. And then alkene to form two carbonyl compound. This is ozonolysis reaction. I will not explain. Okay, I will explain here this reaction from 3 degree alcohol halide to alkene, how formed these things. And B2 form new two carbonyl compounds. That means it will be either 2 aldehyde or 2 ketone, or 1 mole aldehyde or 1 mole ketone is formed by ozonolysis reaction, then hydrolysis reaction. Okay, orbital structure of benzene. Look, this is the benzene molecular formula, C6H6. Okay, benzene molecular formula C6H6. This is the benzene 2 structure. This is the Kekulo structure. We write this Kekulo structure 1, 2 Kekulo structure, and this is the sigma bond sp2. In the carbon contain benzene carbon contain sp2 hybridized. There is a 6 pz orbital. This is the 1 pz orbital, 2 pz orbital, 3 pz orbital. This is the dumbbell shape. This is the pz orbital. This is the delocalized pi electrons. This is the here is the electron. The top all form a delocalized electron. In the bottom delocalized pi electrons. This is the benzene simplified depiction. Okay, benzene contain, this is the 6 carbon sigma bond. This is the carbon sigma bond, 1 carbon sigma bond, 2 carbon 3, 4, 5, 6. So benzene contain 6 carbon sigma bond. All are equal. And also 6 carbon nitrogen sigma bond. This is the carbon and nitrogen. 6 carbon nitrogen sigma bonds. 6 carbon nitrogen sigma bonds, all are equal. This is the carbon atom, 1, 2, 3, 4, 5, 6 carbon atom. Each carbon atom is sp2 hybridized. Okay, there are p orbitals on each carbon atom. There is a p orbital in each carbon atom. Each carbon atom there is a this p orbital form resonance is the top pi bond here below and from benzene structure. Benzene is a 6 carbon cyclic planar compound. Benzene is a 6 carbon cyclic planar compound. each carbon-carbon bond length is equal. Carbon-carbon bond length is equal, and its value is 1.39 angstrom or 0.139 nanometer. We know 1 nanometer equal to 1 times 10 to the power minus 9 meter. Okay, this 1.39 angstrom or 0.139 nanometer or carbon-carbon bond length. All 6 hydrogen bonds are equivalent. Carbon-hydrogen bond length is 1.09 angstrom or 0.109 nanometer. Okay, this hydrogen hydrogen bond angle is 120 degree. All carbon in benzene are sp2 hybridized. Carbon hydrogen bond contain sp2 as sigma bond. Carbon contain sp2 sigma bond. Carbon bond length is in alkane. Carbon bond length in alkane is 0.14 nanometer or 1.54 angstrom. Carbon bond length in alkene is 0.134 nanometer. It is decreases 1.34 nanometer or 1.34 angstrom. Carbon bond length in benzene is 0.139 nanometer or 0.139 angstrom. Look, this is the benzene. Carbon bond length is between single bond and double bond. This is the single bond length is highest bond length, and double bond length is 1.134 nanometer. But it is between carbon bond length in benzene is 0.139 nanometer. It is the between carbon single bond and double bond. So we can't say it is contain carbon benzene. Carbon double bond in benzene is neither single bond nor double bond because it is between them. Okay, this look bond length is 0.139. It is between 1.154 and 0.134. Have you any class today? No class. Okay. Benzene structure. Okay, I should save this thing. Okay, look SM. Okay, look there is a now. What are the topics now? Oh, I want to show the orbital structure of benzene. Orbital structure of benzene. Okay, orbital structure of benzene. Sorry, orbital structure of benzene. Okay, look, this is benzene. Okay, benzene contain which bond? sp2 hybridized. Okay, carbon is the central. Carbon contain, we know, carbon 6 atom. This is the 6 electron, 1s2, 2s2, 2p2. Okay, when carbon is excited state, carbon unstable state. Okay, carbon 1s2, two px Okay, 1s and 2p, 1s and 2p. This is the sp, 1s, 2p, sp2 hybridized. Okay, one carbon is sp2 hybridized. In benzene, carbon is sp2 hybridized. Look, one is unhybridized orbital, pz is remaining. So in a carbon, benzene, carbon is sp2 hybridized. We know the sp2 hybridized. How this sp2 hybridized? One s orbital, and here is a 2p orbital. We know this one s orbital is spherical, and p orbital is dumbbell, 2p orbital. Okay, when this sp2 hybridized, this it form this way. This carbon is, this is the sp2, one carbon is sp2 hybridized. Okay, this all loop is sp2. So carbon, yes, carbon is sp2, this is sp2. Okay, this one carbon. Yeah, we know benzene is contain 6 carbon. Like here 6 carbon form. One carbon. হয় নাই, আচ্ছা এটা ফিগারটা দেখানো, এটা টাইম ক্লিং, I am showing this there. Like this is sp2, I am showing here. You have seen this sp2. There, this is a one sp2, one carbon. There is a one another sp2, another sp2, another sp2, another sp2. So this is sp2. So this carbon, one sp2, this carbon one sp2. So this bond is sp2 hybridized. Okay, this carbon, this is sp2 hybridized, sp2 hybridized. Okay, now this carbon, we know this thing is sp2. All carbon contain sp2 hybridized, and also here is a hydrogen. So here is a sp2 hybridized, and here is a from carbon and hydrogen. We know carbon, each carbon contain sp2 hybridized. This is sp2, and when the hydrogen attach here, hydrogen contain one, so one s1, hydrogen contain s orbital. Okay, s orbital. Okay, here if one hydrogen add, this is called this is sp2, this is s. So this bond between carbon and hydrogen bond is sp2 s or ssp2. Okay, bond is between carbon and hydrogen in benzene. This is the sp2 s bond name. Okay, this is the bond between this so this bond between carbon and hydrogen is sp2s bond. Okay, this is the sp2s because sp2 hybridized orbital or s orbital of hydrogen. This bond carbon and hydrogen, this is sp2, this is sp2. So this is the bond is between carbon is sp2. Okay, already we have seen this is here one unhybridized p orbital is remaining here. So p orbital here, one p orbital here, one p orbital, unhybridized p orbitals. Each carbon contain one p orbital, 2pz orbital remaining. Okay, so here from partial side by side overlap. It is called pi bond. So pi bond, side by side pi bond form, side by side pi bond form. Okay, side by side pi bond form. Where is it? Look, okay, this is not, this is here a side by side pi bond form. This carbon is side by side, this carbon and this carbon for side by side bond. So this is the pi bond form. Okay, this pi bond is here. I give this is here double bond, double bond, double bond. So here I give pi bond, and here I give pi bond, and here I give pi bond. So this pi bond, this is the Kekulé structure, but it can form here pi bond, this also, this here pi bond, and this also pi bond. So this also form, this way also pi bond form, here also, here also, here. But this is where the actual position is not determined. So we write this way write benzene structure. Okay, double bond position where is not fixed, so we write this way benzene structure. Okay, this is the Kekulé structure of benzene. This is the resonance structure of benzene. Okay, preparation of benzene. Preparation of benzene is, benzene can be formed by 5 ways. Benzene can be formed, preparation of benzene, benzene can be formed from soda benzoate and soda lime. This is soda benzoate, sodium benzoate. Sodium benzoate, when heating sodium benzoate, heating sodium benzoate with soda lime, benzene is formed. And from phenol, this is the phenol, benzene when OH, this is called phenol. Phenol, benzene can be obtained by heating phenol with zinc dust. Phenol, benzene can be obtained by heating phenol with zinc dust. This is the zinc dust. Benzene preparation. Okay, preparation of benzene from ethyne, alkyne, ethyne, carbon-carbon triple bond, ethyne. Benzene can be from the ethyne at 400 to 500 degrees centigrade temperature by passing ethyne in the hot iron tube. If 400 to 300 to 400 to 500 degrees Celsius, if we pass ethyne gas in hot iron tube, benzene is formed. Okay, this benzene can be formed by, if we use nickel catalyst. Here we use iron. If we use nickel catalyst, we can form benzene from ethyne at 70 degrees Celsius. Nickel catalyst if we use. So preparation of benzene from Grignard reagent. We know what is Grignard reagent. This is called alkyl or aryl magnesium halide is called. This is the aryl magnesium halide, or methyl magnesium chloride, ethyl magnesium chloride. This is a methyl or aryl magnesium chloride is called Grignard reagent. If hydrolysis of Grignard reagent form benzene. This is the Grignard reagent because this is alkyl magnesium halide. Alkyl or aryl magnesium halide is called Grignard reagent. Hydrolysis of Grignard reagent form benzene. You have to memorize this reaction. Okay, hydrolysis of benzene with diazonium chloride, or hydrolysis of benzene diazonium chloride. This is a benzene diazonium chloride. If water hydrolyzed dissociated water, water two part joined here, form benzene. So hydrolysis of benzene, benzene diazonium chloride. This is the benzene diazonium chloride. Hydrolysis of benzene diazonium chloride with phosphoric acid in presence of cupric oxide and 300 degrees Celsius form benzene and nitrogen gas. Okay, benzene form. This is the 5 way we can produce benzene. Okay, evaluation. Everyone should unmute. What is leaving group? What is leaving group?